Hello everybody, welcome to my channel. So far, we've discussed how to understand the internal structure of G waves by drawing analogies from concepts like composability and multi-meaning features. But here's a question. Can the internal structure of a G wave be broken down endlessly? The answer is no. The breakdown of any internal structure has a limit, and that limit is defined by the resolution of our human sensory organs. For example, with zero G waves, we can't break things down further than the smallest zero pixel the human eye can perceive in a fleeting moment. Just like how a stock market candlestick chart might show movement per minute, but not per millisecond. So you might have already guessed one of the key built-in attributes of internal structures: time. Every G wave exists within a specific time frame, even if the sensation is in instantaneous. The very fact that our senses can perceive it means there is a measurable temporal window where it exists. Now, let's add another crucial attribute: intensity. Think of how someone calls your name. Sometimes it's loud and sharp, other times it's soft and gentle. Or how the scent of osman, osmanthus flowers becomes stronger the closer you get to the tree. This intensity reflects how forcefully a stimulus hits your sensory system. Each word gives G waves their power to form or reshape impressions in the brain and ultimately determines how stable those impressions are. To make sense of these two properties, time and intensity, we can borrow from physics. Imagine G waves like water waves, sound waves, or electromagnetic waves. This time attribute of an internal structure is like how many waves pass in a certain period, and intensity is like the wave's amplitude. But here's the catch. G waves don't usually follow straight frequency or periodic patterns. They are more fluid and contextual. So, how do these attributes affect G formation? Generally, the longer and more repeated a sensory imprint, the more stable the resulting G becomes. For example, you are more likely to remember a phone number after staring at it for 5 seconds than just glancing at it once. Similarly, stronger intensity increases the likelihood that the G will form and stabilize. If I say something loudly with conviction, it hits harder than a whisper. And this principle applies not just to creating new G's, but also to reactivating reactivating or reshaping existing ones. Longer durations and greater intensity deepen the effect, but only within the physical tolerance of our sensory system. Drinking slightly salty soup is fine, but stuffing your mouth with a spoonful of salt. That's overload. Loud music can be powerful, but if it ruptures your eardrum, it's clearly beyond the threshold. So here's a practical conclusion. Consistent and appropriately intense sensory exposure strengthens memory and experience, something every child intuitively knows, right? This principle appears everywhere in life, even if people don't know about G theory. When a young person sees their crush, they try to gaze longer, hoping to imprint that image into their mind. We pay for entertainment services by time. Teachers assign front row seats to students so they can see and hear better. And concert tickets near the stage, always more expensive. But there's a third attribute we need to talk about, one that's often overlooked but equally vital: discreteness, or how fragmented or distorted an internal structure is compared to a reference standard. Why is the one singled out? Why is this one singled out? Because discreteness has two unique qualities. One, it's always relative, defined in comparison to some reference standard. Two, it, it can affect how G waves travel through the brain. Let me explain with an example. Take the famous melody Ode to Joy. If a professional um, pianist plays it, we hear it clearly and flawlessly. But if a beginner who's only practiced piano for 2 weeks tries to play it, they might miss it might miss he might miss a few notes or mess up the rhythm. Even so, we still recognize the melody. The second version, though, has a higher degree of discreteness because its internal structure deviates more from the original. In this case, the professional version is the reference standard, but here's the twist. That standard is flexible, just like how reference frames in physics are relative. If we reversed it using the beginner's version as the standard, then the pro's version would appear more discrete by comparison. So let's define discreteness as follows. Discreteness is the degree of internal difference between a G-wave's sensory imprint and a chosen referenced standard. For now, this difference can only be roughly understood. It isn't quantifiable yet, but in the future, when we study the smallest indivisible units of internal structures, it might be possible to measure it with precision. Why does discreteness matter? Because it affects how G waves travel and get recognized in the brain. Bring us back to our earlier discussion of fuzzy recognition and mistaken identity. So let's in summary uh, today. 1. The three key attributes of internal G structures are time, intensity, and discreteness. 2. Time and intensity shape how strongly and stably a G wave is formed or recorded. 3. Discreteness reflects how a perception deviates from a known or expected pattern and plays a critical role in brain processing. By understanding these three properties, we move one step closer to decoding the mechanics of the mind and how reality itself is constructed inside us. Stay tuned for the next chapter where we'll go even deeper. So that's the content today. See you next time. Bye bye.